I'd like to welcome everyone to today's Trinity Forum, and we're absolutely delighted that Jim Brewster is here with us to join us. You'll be seeing him shortly on the screen. Jim is a senior service hydrologist at the National Weather Service Forecast Office in Binghamton. He has been here with us. Hold it. He's worked in the dual role of both hydrologist, which is water, and meteorologist, which is weather, for the National Weather Service for the past 30 years, spending most of his time here in the upper Susquehanna region. He holds a Bachelor's of Science in Meteorology from North Vermont University in Linden. In 2012, he was awarded the National Weather Service Isaac M. Klein Award in Hydrology for specific forecast services related to the catastrophic flood of September 2011. So we have a real star with us today. He is responsible for day-to-day management of all hydrology operations, including forecasting, interagency collaboration, geospatial data management, hydrologic research, and staff training. So without further ado, Jim, welcome to Trinity. We have some people here in the common room and other people online. We're looking forward to what you have to say, and perhaps some questions and answers at the end. So I'm going to turn it over to our high-tech IT team to go from there. I'll mute myself now. Maybe. Maybe. Welcome.
Thanks. I'm here.
Okay.
Just tell me when to go.
You can go right now.
Okay. My presentation is up for everybody.
Yes.
Okay. All right. Well, thank you. I will start. I have several slides to go over, and special thanks to Susan and the Trinity group for inviting myself on behalf of the National Weather Service to speak to you today. And an extra special thank you to Susan for being one of my river ice spotters there on the lower part of the Shenango, upper part of the Susquehanna region. We can talk more at the very end about volunteerism if you'd like to know more about that. But first of all, you were asked, or I was asked to take a look at some extreme weather trends in central New York, or at least something about extreme weather. And so I thought I would look at the long-term and short-term trends that we've seen over time. And then if that was not the appropriate take, maybe at the end, if we have time, I can show you our repository of historical extreme events that we have recorded and on our website, where you can peruse any of the bigger events and snowstorms and tornadoes and take a look back at that. But first of all, there we go. Okay, that's me. We don't need to talk about that introduction slide there because of Susan's wonderful introduction. But I do have to go over some governmentese, because I think you should know exactly where the National Weather Service comes from. There may be a few of you left who remember, or not left, but who are there, sorry, who remember us as the Weather Bureau way back. Yes. And that actually has not been the case for us since about 1970, when we were regrouped under the Department of Commerce and NOAA, the National Oceanic and Atmospheric Administration, and then there we are in the National Weather Service as an agency within that hierarchy. But yes, the National Weather Service is part of the federal government and actually has been since about 1870. There are 122 weather forecast offices currently across the country, and that also includes OCONUS sites, such as several offices in Alaska, one in Hawaii. We even have an office in Guam and one way out there on Pago Pago in the American Samoan territory, and we do have an office over in San Juan. The image on the lower right part of the screen is my responsibility area, so we do cover quite a bit of real estate in central New York and even some counties across northeast Pennsylvania. So So we're quite a big agency, and we do take actually a lot of pride in the fact that we are very field oriented down to the regional office, so we can be right there for folks in the public to provide our services. So what are those services? Well, of course, we do many things from data collection, but the real big one is we talk about and we look for and warn for the hazards, the real big hazards, and even sometimes the small hazards as they come through. And our mission is the protection of life and property, just like a firefighter or a police officer or other entities such as that. We strive to protect life and property. And then, of course, because we're under the Department of Commerce, we also have a little bit of a peripheral role in enhancing the national economy. Our forecasts and watches and warnings hopefully do help to save money, in some and on a big scale. So this is the 2021 weather fatality tally, if you will, across the nation. So our goal, again, is to try to reduce those numbers on the red columns. Those are all the fatalities for 21. The other bars are just basic averages over 10 and 30 years. So you can see here, we continue to have basically heat and flooding as our number one hazard that will kill people throughout the nation. Another one that's kind of obviously more important for our marine offices are the rip currents, and those are very dangerous. I actually happened to see one or several actually this year. My first time on Hatteras Island on vacation, and they're pretty amazing. I've only seen pictures before, but then to see one live, it's understandable why those are a real hazard. So a couple of disclaimers as we dive into the elephant in the room of climate change. I am a meteorologist practicing in hydrology. I am not an expert in climate change, science, or policy. Just want to make that clear. There are significant distinctions between climate scientists and what I do and what my local partners do, and actually all the meteorologists across the Weather Service. We have a cursory understanding of what's going on, but we certainly do not partake in any of the decision making when it comes to climate. We need to understand climate change because of, well, it affects what we do on a daily and weekly and monthly basis. With that, there's kind of a corollary in the second one. This is a politics-free zone today. I will not be engaging in any of that if it comes up, nor will I, inject my own personal views, and I will try to keep things very straightforward with data. However, if one does slip out, then that does not represent my agencies or any other entity. So what we're going to talk about today, I'll show you some worldwide data, then we'll bring it down into Central New York local data as far as how what we're seeing in terms of this whole climate change and extreme weather issue. We'll touch on whether or not the data you might have heard has been quote unquote manipulated. Then I'll get into talking about extreme weather trends, talk about Central New York's some impacts to the future if this continues. And then again, I'll talk about how folks can be citizen scientists in one way or the other. So let's get right into it. The climate data is, and all of the climate scientists are pretty much at these regional centers, with the big one, the clearinghouse for all climate data known to man, pretty much, is housed in Asheville, North Carolina. But there are sub-agencies, not agencies. There are regional headquarters for climate data. The one closest to us is actually associated with Cornell in Ithaca. They are NOAA employees or somewhat contractor employees that manage the Northeast regional climate data and questions and things like that. So if you have any real pressing climate questions, those are the folks that I can get you in touch with, or you can look them up on your own. So we'll talk about the data, and there he is. So there is a scientific consensus among climate scientists. There are 97% of climate scientists agree that the Earth is warming, and it is caused by human activity. Obviously, that leaves a little bit of wiggle room in their peer circle. And then I have no idea what the percentages of meteorologists, atmospheric scientists, and whatnot. The amount of greenhouse gases has increased. We've measured that in the last century. Those are facts. The warming is not globally uniform, though. Certain parts of the world are either warming faster than other parts of the world, or in some cases there has been some measured cooling over the long period of time, such as in the southeast U.S. to a degree, or the North Atlantic. And so when the climate scientists look at everything, it's not just your backyard temperature measurement. It is. That's a tiny part of the big picture, but they're looking at ocean temperatures, land temperatures, and we even have satellites that are measuring the entire atmospheric column, which they've been doing that since about 1978 or 9. So I'm going to start hitting you with a lot of graphs here, and I'll try to explain them as reasonably well as possible. But this is a very long-term graph of temperatures taken from different measurement methodologies, and there's a lot of proxying going on, since observations really with any kind of robust authority and collection and quality control have really only been going on since I'd say right after the Civil War, during the Reconstruction period, and then certainly we're now having temperature and all kinds of atmospheric parameters measured in a very high density network now. But as you go back in time, you had to use ice cores, tree rings, or the current scientists even have to look at that data. So it's much more of a proxy and not a direct measurement. You can get some information out of it, and it's all we have. So this chart just shows that the basic cycles from the beginning of essentially time, if you will, on this scale. And it highlights that we did have a medieval warm period. You can see the other warm periods, and that would be any of the bumps above the 0 line here would be a warm period, and then you'd have several cooling periods measured. And so you can kind of get a general trend. And then the black line is pretty much since the late 1800s and up through now, with a pretty sharp change in the curve there. But certainly we had some notable periods, the medieval warm period, and then coming out of we're now coming out of or still coming out of the Little Ice Age, which was basically the 1600s through the late 1800s. And the numbers do show that since of those Middle Age periods, the past 30 years have been the warmest in these type of records. Just another way to look at this, for the global land and ocean temperatures, they took an average of the 20th century temperatures. So this chart actually starts back in 1880, and then you take the difference of the measured annual temperatures across the country, across the world. This one's the world, and a data set. And you compare it to what would be normal, and you set normal as, let's say, 0 degrees here. And really all this chart shows is that there was a pretty cool period from the late 1800s through the first part of the 20th century. And then we've been warming really since the 1940s, or we've had an anomalous warmth. All the way up, and this chart does go to about 2021 or 22. So just some raw statistics here. 2022 was the 6th warmest year since 1880. Since the last roughly 8 to 10 years, we've had the 10 warmest on record, and 2016 has been the warmest since 1880. And this will come up here in a few slides, but I do want to make note that this is the NOAA global data set, okay? And I'll show you some differences as to why I'm actually pointing out that this is the NOAA data set as we go forward here. And then last year, just an average anomaly, temperature anomaly graph or image of the globe. And take a look here. So this pretty much shows, so it's 1 year's worth of of data anomaly compared to normal temperatures as calculated from 1991 to 2020 around the globe. And so the warmer areas, the warmer colors correspond with warmer areas. The cooler colors correspond with cooler areas. And the one thing I want to point out here is, like I said, not the globe doesn't warm and equally. The whole globe itself is not necessarily every year warming. And so look at the temperatures out here in the Eastern Pacific. I don't know if you can see my cursor, but there's a cool area here in the Eastern Pacific. That's your La Nina signal showing up in the ocean temperatures. And then when you have a La Nina signal, as we've had for the past 3 years, that does tend to mean that the northern plains and central Canada will actually turn out to be cooler, because all of these signals are definitely linked to changing weather patterns on a seasonal basis in the northern hemisphere. So there may have been, you may have heard, I don't know what kind of chatter you hear or read about or talk about, but you may have heard that there are claims of data manipulation going on with this whole climate thing. And that is true to some degree. However, the climate scientists have stated that, and this is a fact, we measure things differently compared to, the 1880s or the early 1900s and so forth. And so that's the guy on the left near the what's called the Cotton Region shelter. So you grab your mercury and glass thermometer and you're measuring it that way. And then of course we've come into more of the electronic age, where we're having thermal sensors and wind sensors and measuring things and becoming more standardized and calibrated. And so there was a consensus to say, hey, things have changed. And so what they did was, in one case, with the ocean temperatures, they warmed the early part of the 20th century, and then pretty much left alone anything from the 1940s. And the reason is because of the data, the process of capturing that data was, that's what they had to do, was throw a bucket over the side of the ship and collect a water sample. And so from the time, you're only skimming the top of the water essentially. And so from the time you scoop that up, theoretically, to the time you measure it, after you pulled it over the side and got the thermometer in it, it had somewhat of a bias. So anyway, the statisticians said that it would be okay to change that data a little bit, especially since now we've had a more consistent measurement package going on since the 1940s, where they decided to put the thermal sensors just in the intake of the engine. So there's obviously some issues even with that per se, but that is the standard, and all ships measuring ocean temperatures now take it in the water to cool the engines comes in, and so they measure it just at the point where it's coming in. So they did make changes there. And then over land, and here's where I'm getting back to the point about when I declared that we have the NOAA data set. So again, the statisticians and climatologists took a look at the data over the land as measured by our Volunteer Cooperative Observer Network, who again has been around since the late 1800s in many sites, including several of ours. We have some of the oldest sites in the country, one being Ithaca or Cornell, and one being out at Cooperstown. One can argue that we've also had a pretty lengthy network here of observation right in the Binghamton area. However, from the 1800s to about the late 1960s, that was downtown at the and most of it was at the old post office. But then in 1951, of course, we moved it up to the airport. So that's kind of because of elevation, it really does make it a different climate. And I know that's a little bit of a contention around here, but it is what it is. So we have the two data sets. We have the data set that was really measured by humans, which goes into the climate record. And then we have the data set that was statistically adjusted, and that's that NOAA data set. So what I've done here is I just subtracted them, very simply. And so the graph here is showing basically starts in 1893 and goes all the way to the present day. And it shows how much of a change was made to that NOAA data set. It was essentially what they've done is they warmed it by about 2.5 to 3.5 degrees. So the reason you're seeing negatives here is because basically what I'm showing is no, excuse me, I'm getting confused. They cooled the 30s and the 40s, and basically that whole time period from 1895 to almost 1980, they cooled the warm period of the 1930s and so forth by as much as 2 to 3 degrees. I mean, they cooled the whole data set to some degree, but it's much less, only about a degree here in modern times. So basically, I'm just pointing this out that there are different data sets to look at. And the official NOAA one is the one that's being used for decision making around different circles. But the raw data is still out there in some ways and can be found. And so they really did wind up cooling the hot times we had in the 30s and 50s, which in some ways can play with the records we're talking about in these times, where they say it's been the warmest since the 1880s. It depends on the data set you look at, because if you actually look at the 30s, we're pretty close in the raw data set. And I'll let you come up with your own conclusions on that. But that's what I'm seeing because I have access to both data sets. Okay. So is climate change human caused? The answer from the climate scientists is absolutely yes. Other scientists, I think it's complicated. I think it's the oceans and the atmosphere is a very complicated situation. That's shown over time, natural tendencies. However, it's really hard to necessarily dispute the data that is out there in showing that we are in a warming period, which we really would have had to have been anyway, coming out of the little ice age of the 16 to 1800s. So it's just a matter of interpretation. But the Earth is certainly warming. There's very little doubt about that. So we talk about CO2, and these two traces on this chart show the temperature in red and the measurement of the CO2 in blue, and so they're fairly close in pattern anyway. And so there's still some issue as to what's the chicken and what's the egg, which is happening first. There's some of the data does show actually temperatures warming before CO2 increases, which there is some legitimate physics behind that. Otherwise, we're showing CO2 parts per million in the atmosphere, similar to what it was, many eons ago. So in theory, I think just the expectation, if we're up at that level of 400 or so, a little over 400 parts per million, and we know from the proxy rings that it was the temperatures were a couple to 3 degrees warmer, with somewhat lower parts per million of say around 300, then it stands to reason that if we have higher temperatures, or we should be warmer than that with more carbon dioxide, and that will obviously turn into melting of glaciers, which is happening, and we should have a higher sea level. So there are definitely signals showing that the Earth is warming, and it's important to be monitoring that. So how do they monitor, and how do they tell the difference between natural cycles and non-natural cycles, or human-induced warming? And basically, we run models. Climate scientists run models. Meteorologists run models of different ways, and for different reasons. But we run models, And models have their own issues, regardless of, you put data in, you get data out. So if you put good data in, well, theoretically you're supposed to get good data out, and vice versa. But anyway, so some of these models show that without human effects, the warming would not be as dramatic as it is, and that may or may not be true. The models are showing it to be true on the top graphic there, but you can see the more data you put in, and if you change the variables in the bottom graph, basically shows several curves to warming coming up for the future. And so the lowest curve there is with reduced emissions or minimal emissions, and there's just kind of some warming here for the next 50 years, and then if it's curtailed, we tail off, and then if it's not curtailed, it just the model shows it continuing to rise and rise and rise. So these are the things that are the science that's driving decisions around the globe, and it is what it is. It's the data we have. It's the data that's being pushed out, and just like in when we get down to my level in meteorology, it's we have to make decisions on the data that we're seeing, right or wrong, and most of the time we have varying levels of confidence at the meteorologist level of whether or not we're going to be right or wrong. And when in particular when we see the snow events or the winter events coming in, and some area is going to be all snow and some area is going to be rain, and then it's the in between where we have the lowest confidence. So that's just kind of a comparison between the two disciplines. Just another way of talking about, is the science settled? You hear that often, and I promised I wouldn't put my opinion in there, but I think this one's going to slip through. So we look at the graph there, and again in the gray, try to explain this. The gray is a modeling, so it's a forecast, if you will, to the right of that line, and the various different colored graph images on the graph, lines on the graph, are actual measurements from different data sets. So we've got land measurements, satellite measurements, a combination of both, and you can see that we're up to about 2021 maybe on the chart, and the actual measurements are running a little bit on the lower end of the curve of that particular model. Now, if another model is run, perhaps these temperature curves are smack dab in the average, and everything is hunky dory. But that would imply that the newer model, if there was one, would actually be a little bit cooler, or yes, a little bit cooler than what is being projected here. So currently, a lot of the data sets kind of say that, hey, we're running on the lower end of the warming, still showing warming. There's almost no debate about that. I don't think there is a debate about that. But when you start getting into how the rates are of warming, that's what people are talking about. So I think it depends on the discipline circle you talk to, whether or not the science is settled or not. But I argue that physicists are still debating gravity on some levels. Yes, we have a known fact that if something falls, it's going to fall at 9.8 meters per second and hit you on the head. There's no question. There's no doubt about that. But yet, at the same time, gravity is not settled. So how can climate science be settled? And if it was settled, why would we be studying it, really? I don't know. Just some food for thought there. So let's get down to what we're seeing here. After all that, 3 of the 5 warmest years have occurred, since 2006. Again, this is the NOAA database. It's an annual average temperature as measured here for a climate division that encompasses most of central New York and also the Catskills. So there's a lot of stations that are showing up in this data. It's not just the Binghamton Airport, because I wanted to go back into the 1800s. But anyway, the trend line does show some significant warming. And then it's you could see there was a warm period in the 30s and 40s. And then, of course, pretty much all of us remember the colder times we had in the more prolonged colder times, I should say, we had throughout the 60s and the 70s and even a part of the 80s. But the thing to note, we have a lot of variability It's year by year, it's either up or down or up or down or up or down. It's just these longer term trends did happen to show. There was actually a pretty chilly period in the early 1900s before we got to the warm part of the 30s. So there's a little bit of cyclical natural cycles to this, but the trend line can see that temperatures are warming at perhaps a more substantial rate since the late 70s here. And most of your colder temperature years are before World War II. So it is really kind of a modern warming. So now I took a look at the data from the raw, different data set here, different chart, just to show you how the raw data picks up on that cold period in the early part of the 20th century, shows the warm period of the 30s to about the 60s. Then we get into that colder period for almost 40 years, and now we're into a warmer period. But you can actually see the distinct difference here of slightly cooler warmth in our time now as compared to those Dust Bowl and drought years. Again, we go back to the argument: is it statistically sound to leave the raw data alone? That's for you to decide. Precipitation, a whole different story about that. I think there's very little to debate about precipitation. There's a linear trend on this graph. Again, NOAA climate data set showing a definite increase in precipitation going on, and actually you can see with these spikes, this would indicate some of your more extreme years. And so that has actually occurred since we came out of the drought of the 60s. We've actually had more years where we've had some pretty decent heavy rain spikes showing up annually, and this is around central New York. Four to the 5 wettest years since 1996. We had one which was pretty decent in 1977, and then you can't find a really dry year until you go back to 2001, and everything before that is ancient history. With, of course, the pretty pronounced drought of the 60s around here and really everywhere. So precipitation, I think, is a little bit less controversial than temperature. Just another way of looking at that is through an index we use to monitor droughts. Basically shows the same thing as the precipitation data, except we're taking into account some other parameters that go into droughts, such as soils and well, actually temperature goes into this as well as the moisture. But again, really standing out with some dry periods prior to the 70s, and then we definitely have seen more wet years since the mid 70s. And even if we've had dry years, they certainly haven't been as dominant as what we saw prior to about 1975 or so. I'm gonna have to speed up a little bit here. So then I took a look at actual extreme rainfall days. This again comes out of the local climate, the raw climate data, and but really no dispute here. A lot more blue indicating a lot more extreme precipitation, and the way I defined it here is over an inch in a day. Typically we use over 2 inches in a day, but it was a very sparse data set, even for us here. So I chose the 1 inch just to have you better able to see the pattern. And so yeah, since certainly the early 2000s, we've had less years where with less days of an inch or more of rain. There's some variability even going back into the drought periods, but yet we had one year here where there was pretty much less than normal days having an inch or more of rain. So this is obviously very important for us, as flooding is already New York's greatest and costliest weather hazard, above them all. And there's a lot of the rural communities aren't able to handle this increase in moisture. And tying everything together, with an increase in temperature, you have the ability of the atmosphere to hold more moisture. So the fact that we are at least generally warming the planet does translate into some higher amounts of precipitation and more frequent. So with that, I thought I would dive into the snowfall aspect of things, and this one's not as clear really at all. And it shows that snowfall can have extremely high variability. The Binghamton chart is on the left since the early 1950s, where we have the airport data, and the trend line is the dashed black line. And I don't know, if you really look close, I think there's actually an upward trend in the snowfall, which is a little bit counterintuitive to what you would expect in a warmer climate. There are reasons for that. But then I looked at the Ithaca snowfall, which of course goes much further back, and the trend line is actually a stronger positive trend line. However, I think that has to do with the beginning and ending of the data set, because if you take from about the late 50s, early 60s, and you put a trend line from there, you actually do see a bit of a downward trend in snowfall. And if you kind of put your eyes looking at both sides of the chart, you have about 55 to 60 inches of snow back here in the early part of the data set, and now you're kind of right in there at about showing many years of 60, or around 60 to 65 is kind of your shorter average there. So interestingly enough, you had this was a cold period, but you had, well, compared to the 60s and 70s, you had less snow, and then we hit the mother lode of colder temperatures and snowy periods, and then now we've kind of going into a downtrend. It's a little hard to correlate that with a warming climate, since the original part of the data set was cold, but I guess we'll have to wait and see on that. There's also a little bit of a caveat for both Ithaca and Binghamton, is the fact that we are in somewhat of the lake effect belts, especially Ithaca being off of Cayuga Lake, which can pick up Finger Lake snow, and warmer lakes will be the moisture and energy source for more lake effect snow. So in essence, a warmer climate would be a healthy promotion for higher snow totals, believe it or not, because of the mechanism of lake effect snow. So what's extreme weather in Broome County? This is kind of my list, but it is based on about 30 years of experience. And it's kind of a ranking, and I would say river flooding and flash flooding leads the charge, followed by winter hazards, and then maybe a close tie between lightning and severe weather, such as tornadoes and winds. And I think I gave the nod to lightning because we have more just mundane thunderstorms that will produce lightning as opposed to the severe ones. So there's generally a hazard anyway from lightning. And then lastly, probably cold and heat. I think we tend to be in a fairly temperate climate where we can manage those better, but they are still the number one, or heat especially is the number one threat to humans in the country. So trading off with river and flash flooding. So let's take a closer look at that. Snowstorm extremes. We have a couple of recent big snow events in history that we all remember well. And so this chart shows the annual number of days with snowfall greater than 1 foot. Really not much to say about this. There's really no trend. We generally get 1 to 2 big snow events per year. And so the time frame there, about 2002 to 2003, we had about 3 of those. So really that one jumps out. And then just a couple of years ago, we had a couple of big ones roll through. But 2016, 17, and 17 and 18 period where we had the March snowstorm, this is the only one of the year. So did it provide 30 inches and 40 inches of snow on a couple of the most recent storms? Yes. But again, so you can loosely tie in the fact that we have, somewhat warmer climate, more energy, more moisture that we're seeing in the trends overall. to tie into that, but there's a lot more of the physics that goes into producing those copious amounts of snowfall. We've had 30 inches before in the past. The one more statistic with snowfall to look at in terms of kind of how severe a winter is to look at what are called snow depth days. And so the thought is that the more snow you have on the ground for a longer period of time in a winter is a little bit more of a nuisance and a headache to the social function and just day-to-day life. So you can kind of measure that statistic in terms of who's bothered, and what kind of influences we are in impact we have on our lives. And so that shows a little bit better of a trend downward in more recent times. We have less snow depth on the ground, or significant snow depth on the ground per winter than certainly the 60s and 70s. You had a lot of times over 40 days and even double that. And then it really the time of the superstorm back in '93, which lasted. That was actually there were several storms that season, and that snow just lasted. And then, of course, that was a later season March event, and so it just kind of piled up. But since then, we've had a lot fewer winters with more than 40 days of 6 inches or more snow on the ground. So that may be an indicator of kind of the extremes or lessening of extremes in the big picture around the Binghamton area. So now we get into my bailiwick, if you will be flash flooding and floods. Flash flood reports only date back to about 1996, and so there has been a little bit of an uptrend on at least the moving average. However, we have to be careful with data sets of flash flooding because these are subjective. They're reports from people based on damage or observation, and also the way that we tracked the reports earlier on. We would actually, from about the record here of 96 to 2006, you could put in a flash flood event as countywide. So I found a lot of those in the Broome County statistics where there may have been flash floods all over the place, but the event was categorized as countywide. And ever since 2006, every single report of every single location that comes in with someone saying, hey, Snake Creek is flooding near coming out of Conklin towards Binghamton there, or Little Snake Creek, that one goes in. Thomas Creek out here in the town of Shenango is flooding. That report goes in. So a little bit of disparity in the trend. I mean, we may not have seen an actual uptick in flash flooding, but anyway, that's the data we have, and so I just wanted to point that out. That it's still, we get 20. Some years we get over 20 reports a year of flash flooding, and others we get none. So again, a lot of weather has variability embedded in it naturally. So to be more objective, I did a research project on the rivers a few years ago now. I looked at the longest period record gauges on our rivers, and one is Conklin, one is Shenango Forks, and the other is on the Chemung in the southern tier here. And so I wanted to take a look at the trends of flooding. And this is objective binary. It flooded or it didn't. So it's a little bit better of a database. That's a little bit less disputable, whereas it's not subjective like just receiving a report. So here's some definitions real quick. Minor flooding is defined as the minimal or no property. It's the water's out of banks. It might be causing some issues like roads and everything, but it's generally just the first tier of concern. And then when you get into your moderate or major flooding is when we obviously start getting into properties and structures and extensive deep inundation, as we saw in 2006 and 11 around here. So I or my predecessors and my counterparts all set these. We're the ones that set these stages at all of the USGS gauges. So I just thought I'd throw that in there to see how they come about. We do it. So here's the numbers. Total number of floods by year at those three locations, all combined, going back to 1935. 10-year moving average trend, we're actually seeing, generally speaking, with a lot of high variability, less flooding or less counts of flooding at these gauges combined. So back in the 30s, pretty much every year had a decent amount of flooding going on. Here's your Agnes. Here's your Connie, Diane, Eloise years. Here's your winter flood of '96, and then of course here's your 2011, and well, here's the 2004, 5, 6 years, which were mostly over in the Delaware, but still caught us too, and in the Susquehanna. So generally a kind of a sliding average here, and a downtrend on total flooding. So let's break it down towards the cool season floods. So these are your winter, spring snowmelt floods. Again, 1935 to the present, and again, kind of seeing a downtrend in the cool season floods as well, which you would expect, since the other one considered the whole data set. So at least part of it should be showing the same trends. But I think what's important to show is there was a lot of flooding going on back in the 30s to the 60s. And then we've got several years where there isn't. And what happened between the 30s and the 60s, and even to an extent the 70s floods, is the flood mitigation. East Sydney, Whitney Point, Binghamton flood walls, which aren't included in the study. I specifically kind of kept this out of it. I wanted to stay into a more natural basin flow as opposed to the regulation, but it's hard to avoid regulation in the Susquehanna. So meaning flood control regulation. But you can definitely see there's a lot more gaps in the data. So how about the warm season, summer floods, and and picking up the hurricane floods as well as you kind of get into the fall? With the exception of just showing the peak years, really not much of a trend shown here. And that's strictly because the warm season tends to be, driven by hurricanes. So you don't get a hurricane, you pretty much don't get a flood. With the exception of 1935, which was a thunderstorm complex that sat up across the lower Finger Lakes and up in the Tafneoga Basin and the Shenango Basin, which poured down on top of Binghamton. So it wasn't necessarily that much of a Susquehanna flood per se, but it definitely showed up for, the Forks gauge and so forth. So that was just a strict thunderstorm flood without any tropical influence. But these are all pretty much tropical influence floods here in the 70s, and of course in the mid 2000s, and certainly 2011. So moderate to major floods by year, very similar trend. Linear trend is certainly down from the 30s, and the moving average trend is also decreasing. But at the same time, the 2011 stands out with number of moderate and major floods that year were 5, and that's quite a bit for those 3 gauges. Typically, you just have 1 or less than 1 on the average for a flood, a moderate to major flood over the course of time. Again, a lot of variability depending on certainly the hurricane seasons, and then usually the winter spring flood events don't get to the moderate level. Every once in a while they'll get to the moderate flood level, but generally speaking they're minor floods. And then just really quick, what's the average height of a flood stage by year? 2 to 3 feet. Again, though, I think we pick up an interesting trend here in the mid 2000s and the 2011 flood, where those floods were significantly high, above normal, and even more so than the Agnes flood, which was only about 6 to 7 feet above, or 6.5 feet above normal, and these were considerably bigger floods, which that can go into the a conclusion can be made that yes, we did get more rain with those. And we got more intense rain, so the runoff was a lot faster than perhaps it was in 72. So there's a little bit of an interesting nugget we can pull out of this data set as to whether or not it's playing into extreme weather around here. So future projections, real quick. These again go back to those models we were talking about, general circulation or regional models. Sorry about that. Had to take a drink there. A lot of spaghetti on the chart here, but generally says that if you can see the bottom charts and you can see the colors in that, basically prior to the significant warming, precipitation was a summer and a fall spike, and now it's refocusing towards more of a winter and a spring, or it will be going forward to more of a winter and a spring problem, according to these models. The gray spaghetti, you can just sort of see an upward trend to make that conclusion here in the future, which this chart goes out to about 2075. The prediction is that the precipitation extremes will be focused more in the winter and the spring for our area. A little bit plainer signal here in this depiction. It just shows drier summers and wetter winters. Will that mean snowier? Hard to say. Outside of the pure or inside the pure lake effect belts, probably so, because a warmer, wetter environment will induce lake effect, because we're still going to be cold. It's not, we have to go through the whole orbit of the sun, so we can't avoid that. So winters will still be cold and summers will still be warm, but it looks like they might be drier. And this just shows how the stream flows will respond. The January and February, we may have, and that's the chart on the part of the chart on the left here, just shows a flow change. So they're just showing in this that January and February compared to the averages from 1971 to 2000, and the forecast projections from 2041 to 2070 shows more stream flow in the winter months. December's over here, and either less or normal stream flows in the spring and summer months. So for my concern, if I'm really thinking about it, is I'll be perhaps having to refocus some of my some of the things that I write out to the emergency management partners may have to come out a little earlier in the winter, as opposed to your typical March, April flood problem time frame. So right now is when I'm starting to write winter spring flood outlooks this time of year, and maybe I'll have to back that up here, and well, I'll be retired by 2041. I'm long gone, but my counterparts may have to start thinking about putting this information about seasonal flooding out sooner. So that's how we're looking at these projected changes. So really just some key messages. Global analysis, no matter which data set you want to look at, does show warming and wetter and a moister climate. Point analyses show signals consistent with the globe. So the point analyses being here in Binghamton, or just the southern tier data sets that I used. Snowfall might be trending down, but extreme winter events kind of showed no long-term trends. And then going back to the flooding days are down, but the severity of the floods may be getting worse. I think we probably have seen indication of that. Will that continue? Well, that depends on the modeling. One could presume that that would continue. And it's also very important to note when assessing the differences between climate and extreme weather. Weather goes into climate as far as the record goes, but the natural variances are very important in looking at extreme weather and also the climate change. We're not, we have to, you can't, basically the point I'm trying to make is not every extreme weather event can be attributed to climate change directly. You may kind of see that on the news a lot, But that's something that has to be assessed, because we've had these extreme weather events in the past, and even during the cool periods. So that's just some food for thought there. And I believe that brings me to my citizen scientist plug. So I have lots of opportunities, like Susan's involved with our river ice network, which of course in the last few years hasn't been all that exciting. But nonetheless, we do monitor the river ice, because that, as you know, can cause some problems over time. So we do have one where you can be a rain observer, and it's called COCORAS, or Community Collaborative Rain, Hail, and Snow Network. We have a lot of observers across central New York and across the country. There's, I don't know, 20 or 30,000, maybe even more. Might be a little bit behind on the numbers there, but this is a supplemental network compared to the official observers that we set up with equipment and take care of throughout the year, that provide the official data for us. This is something separate, but it enhances the density of the observing network, because weather is local. You probably know that a thunderstorm can go, and your friends can be talking to you on the phone saying, "Oh, it's raining so hard," and you're saying, "Well, it's sunny here." So that's why the bigger the density of the network, the better we can assess what's going on for both weather and climate. And I really pushed the end of it there, but that is the end. So now, if you have any questions that I might be able to answer, we can open it up.
Thank you very much. This is actually Engineers Week starts today, and this is a really great way to kick it off. But more importantly, there's a lot of questions. I think I have a lot of questions, but let's ask the audience first if you have some thoughts of. You've been here, and what's wonderful is you were here before the big floods, long enough to kind of get a sense of sort of what people think is traditional, and now you've seen, sort of several eras of weather here. So thank you very much for sharing. It's really interesting. So questions? Go ahead, Judy. Sorry.
What about extremes with one day, which we've experienced this week, where you had a 30-degree drop, something like that on Friday, and then a 20-degree rise on Saturday? I'm not looking for a trend here, but does that reflect, what does that reflect, and what should we read into that?
Oh, that's a great question. Which is hard for me to answer, because I don't look into that really as anything except that's weather. I grew up in New England, and I pretty much have heard the same adage here, but the New England adage was, if you wait 5 minutes, the weather will change. Yeah. So
right.
I mean, that's a poor answer from my perspective, but nonetheless, the big swings, I personally can't attribute them to any kind of global change or any kind of these patterns. But we're still going to have Arctic air build up over the Arctics, no matter the Arctic, the Arctic, no matter where, what goes on as far as long-term trends, because the Arctic will still generally be, it's the pole, and it won't get sun for 6 months of the year, and so it will tend to build, and we get a lot of our cold air over northern Siberia, and there's very little data actually out there. So I still think these changes are going to happen. Part of this may be this year and the last couple of years, where we have had these wild swings, could be a little bit of an enhancement from La Nina, because of the way that influences the the global patterns, and it actually allows it keeps the flow of the jet stream more linear, or more west to east, more prevailing, so we stay on the milder side during La Ninas. But when you get the interim buckling, and you've had air up over the Arctic released, down over us, then yeah, we'll get those apparently quicker changes. Whereas if we're in an El Nino pattern, we tend to, as long as one of the North Atlantic signals is also favorable, we can lock more into the colder air, so it doesn't seem as dramatic of a change. So yeah, realistically, I think in the last few years where we have seen these big drops and then big rises has probably been caused a lot by La Nina and an unfavorable North Atlantic signal, where that would help to lock in that colder air. So I'll leave it at that. And
Okay. Well, thank you. And we're happy to have Beverly Dorsey joining us online, and she's lived in Binghamton probably and remembers Binghamton weather longer than your data sets. Well, not quite, but at any rate, before we go, Beverly, it's delightful to see you back and ask if you have any questions or thoughts that you wanted to ask. You always have the best questions, so you get to start.
Thank you for welcoming me. And I find the presentation very interesting, but oh, so overwhelming in its content. That's all I can say. I am trying to fathom most of it, and I hope that I'm doing a decent job. But I find this is these facts and the presentation of these facts makes me remember that we human beings are just a small part of our universe, and yet our activity has quite a serious import on what happens here and maybe worldwide. So that's my reaction right now. But I'm enjoying the program so very, very much. Thank you.
Once again, Beverly, great insight. So we appreciate it. We had a question here. Rob?
I'm Rick Shoemaker, and I plan and spend many, many days on the rivers all over central New York here and through Pennsylvania also. I'd like to give you, your service, your agency, a personal note of gratitude for the data that I reference almost daily. The predictive hydrologic curves that stretches out for the short term, 2 or 3 days, are an invaluable resources for river trip planners like me. Without the real honest stuff that you do, my work enjoyment of the river would be far more hazardous. Thank you.
oh, welcome.
Other questions here?
I got a comment to offer alongside what Jim, and thank you for a wonderful presentation, alongside what Jim stated a few minutes ago. Weather is not definitely local. Over here at our house, it can pour, and 10 minutes away, somebody is having wonderful bright sunshine. What I find interesting is the beginnings of our ability to tie specific weather events into the larger global climate patterns that are emerging, that we are generally summing up under the label of global warming or global heating. So that's just barely beginning to show up in the scientific literature, but it allows us ultimately to connect our local weather patterns and local weather experiences with the larger global climate story all around us.
Yeah. And I have as you started, Peter, it reminded me of a question. When the Weather Service moved from downtown in 1961 to the Hill, has that really changed sort of the relationship between what you're measuring and what we see, those of us who don't live up on the Hill, see? Is there a big difference from downtown to the airport?
So there was even before I got here, there was a study done on temperatures only. And they found that between the data set that was collected, through the downtown observation and the hilltop, it was about a 4-degree difference on average for the high temperatures. It was a study about high temperatures. Low temperatures would be probably a big difference. Actually, I know it is a big difference because I live about 920 feet and the airport is 1,600 feet where the measurement is. Oh, it's actually more than that, but not much. And there'll be times when I will be at, I don't know, let's just say 10 below, and the airport will be 15 or 20. So there would be a marked difference in the valley locations from the airport in temperature. And of course, now if we go into precipitation, it's frequently snowing at the airport, and then I will be, not so much in rain here, but you could be in Bing. I've seen it. I've actually, there was an October event, years ago. We got 10 inches of snow at the airport, and I believe we had a flood watch out for elevations below, say, 1,000 feet. And it was pretty much correct. I don't think it actually flooded, but it certainly could have. And there was rain. So yeah, there's a marked difference in what we see around here from hilltop to valley. So there's a little bit of there's definitely differences. We used to have a cooperative observer measuring an endicott at the wastewater treatment plant, but for some reason they stopped doing that for us. I don't know how long ago, quite a few years now. So we do have some records that are fairly modern. I mean, I'm talking well past the 60s for valley locations that can be compared, but we just don't have anything current or specifically for downtown Binghamton.
So when you hear on the radio or the television a temperature or a prediction, we should adjust that mentally that it's going to be a little warmer, a little colder, depending on the season. It's not going to be spot on, right? Okay, great. Yeah.
Our forecasts. Well, that's another thing. Is what forecast are they reading on the radio? It used to be exclusively, we were it. But there's a lot of private and commercial entities out there now that are putting out forecasts. We should all be pretty close, but when it comes down to it being a difference of 4 degrees here and there. So if you look at our forecast, we're forecasting pretty much for the airport, or at least the one that you're gonna hear. However, there, so you can make a mental note that it would be warmer during the days for sure. Actually, the way we do our forecast now is we forecast on this could be a whole other talk. We forecast on a grid, and we forecast out of a database, and the grid resolution is 2.5 square kilometers. So essentially we're forecasting for several of your backyards. So if you go to our website and are using our website and click on a point or click on your house, then we should actually be pretty close without needing to modify, because the database has terrain and topography incorporated into it. So we are actually seeing the adjustments.
So the school districts, when they're planning whether or not to close school, they have access to this really detailed data for their district.
They can, for sure. Yes.
They could.
And sometimes we get phone calls from them. I'm looking for my, if I can show you real quick here. Am I still sharing?
Yes, you're still sharing.
Oh, okay, good. Real quick, I just wanted to show you our website, and especially the past weather events. If you wanted to go back and review, we have, so at the top here, weather.gov/BGM is how you get to our main site, and then you can find it. You don't have to remember this direct link, but go to past weather. And we try with most of the higher end events to do little summaries. And so you can see we've got severe weather reports from, and of course, like I showed you, we have a pretty wide area, so we do get a lot of events, but not necessarily for Broome specifically. But I mean, we do. But so here's like the May '98 tornadoes. If you wanted to go back and revisit that, which I can do real quick, we've got some charts and summaries and radar and description and tornado pictures of what the radar looked like, and then even some photographs archived here. And you can do that for any kind of most parameters that are high-end impacts. Tornadoes, flooding, got some snowstorms, and I don't even know what's under miscellaneous. Wind events, excessive heat in some cases. So that's another way to take a look at the extreme weather.
This has been super helpful. My nieces, who are now in their 30s, their approach to this was, if it was snowing before 10 o'clock at night, there was going to be school the next day, because that gave the people time to clear the roads. But if it started snowing after 10 o'clock, they could skip school the next day. But that was
Interesting.
yeah. Actually, Allie Sherwood, she used to work with you on the citizen science programs 30 years ago when she was young. Yeah.
Okay.
Alice. Yeah. Okay. So any more questions? Any thoughts? Any comments? Well, we're getting thumbs up. You can't see them, but thumbs up all around the room. So thank you. Oh, Beverly, go ahead.
I was not living in Broome County at the time of that flood in the mid 1930s, but I lived down on Long Island. However, I remember having a friend who lives at the base of Mount Prospect, and she said that the bridge over the Shenango River was totally flooded, and her property, they had to evacuate because of the flooding. And so that was in 1935, and the gentleman from the Weather Bureau said that was the time it was extremely flooding in this area. But as opposed to Long Island, there wasn't that bad weather at all. So it makes me realize how much the climatic changes vary over a relatively short distance. And I just thought back to the fact, well, I was on Long Island in the 1935, and that was Western Long Island, and we did not have to evacuate. So just in the radius of 200 miles, we see what the climatic changes can be.
Well, thank you, Beverly. That's a really wonderful way to, I think, sign off and say to everyone, thank you very much for being here, and to thank Jim Brewster for giving us a really quick. That was fabulous. Thank you.
Thank you.